Hello friends, last time we discussed about inertial mass and gravitational mass. Today we take up their measurements. How we can measure inertial mass and how we can measure gravitational mass. So that is our topic of today. So first we take up measurement of inertial mass. Inertial mass is measured with the help of inertial balance, in which inertia of matter can be used to measure inertial mass. I repeat, inertial mass is measured with the help of inertial balance, in which inertia of matter can be used to measure inertial mass. Now, what is principle of inertial balance? Square of time period of vibration is directly proportional to the mass placed in free end of the balance. That is, T square is directly proportional to M. Here, I repeat, square of time period of vibration is directly proportional to the mass placed in free end of the balance. That is, T square is directly proportional to M mass. Now, what is the construction of inertial balance? First, we try to understand what is the construction of inertial balance. So, let us see. Look at the diagram. It consists of a long strip of metal. This is long strip of metal. The inertial balance consists of a long strip of metal. Number 2, one end of the strip is fixed to a table using G clamp such that its flat surface is vertical so that it can easily vibrate horizontally. Number 3, the other end of the strip supports a pan in which the object to be weighed is kept. So 3 points you remember about inertial balance. It consists of a long strip of metal. One end of the strip is fixed to a table using G clamp such that its flat surface is vertical so that it can easily vibrate horizontally. Number 3, the other end of the strip supports a pan in which the object to be weighed is kept. We remember these 3 points about inertial balance and look at the diagram carefully and try to remember it. Now, what are the factors affecting frequency of vibration of inertial balance? So, when it vibrates, its frequency of vibration depends upon number 1, length of projecting part of the clamp. Number 2, stiffness of the material of the strip. And number 3, the total mass of the pan and the object. I repeat, when inertial balance vibrates, its frequency of vibration depends upon number 1, length of projecting parts. This is length of projecting parts of the clamp, G clamp. Number 2, stiffness of the material of the strip, stiffness of this strip. And third, the total mass of the pan and the object. So these are the 3 factors which affect frequency of vibration. Now, measurement of inertial mass, how we carry out measurement of inertial mass with itself. Let the inertial mass of the body be mb and the mass of the pan be mp. Then the total mass of the pan plus body will be, say, m1 equal to mp plus mb. Now, the body is placed in the pan and is made to vibrate horizontally. The time period of vibration is recorded. Let it be T1. Therefore, M1 is proportional to T1 square. Mark it as equation 1. Now we take another body whose mass is known. Let its known mass be Mk, K for known. Total mass of the pan plus body say be M2 now, and it is equal to Mp plus Mk. The body is placed in the pan and is made to vibrate horizontally. The time period of vibration is recorded again. Let it be T2. Therefore, M2 will be directly proportional to T2 square. Mark it as equation 2. Now, dividing equation 1 by equation 2, we get M1 by M2 is equal to T1 square by T2 square, or M1 will be equal to T1 square by T2 square into M2. Therefore, inertial mass of the body will be Mb will be equal to M1 minus Mp, which we can calculate from the earlier equation that we have quoted in the beginning. Okay. So, because we know M1 is equal to Mb plus Mp, since M1 is known, Mp is known, therefore Mb can be calculated. So, Mb will be equal to M1 minus Mp. Thus, inertial mass of the body Mb can be determined. And now, measurement of gravitational mass. Gravitational mass can be measured by three different methods in three different situations. Number 1, by spring balance. Number 2, by common balance. Number 3, using scientific principles. We take up one by one. Number 1, by spring balance. The principle of spring balance based on Hooke's law, which states that extension of spring is directly proportional to load applied. I repeat, extension of spring is directly proportional to load applied. If mg, which is equal to Fg, Fg means gravitational force, if mg is equal to Hg is the load applied and x is the extension produced in the spring, then x is equal to Fg, or x is equal to Fg by k, or Fg is equal to minus kx, where k is force constant or spring constant. Why I have said minus kx? Minus for restoring force, which is developed into the spring after load is applied in the reverse direction. So for that we put minus always. Here we are not putting minus. Next, in the coming steps, we will put minus. Let us see how it goes. Now you can see in the diagram, this is a spring initial position. When load W is applied, it takes extension x, and a restoring force F REST is developed into the spring in opposite direction to the applied load W equal to mg equal to Fg. Okay. Under the extension of the load, a restoring force is developed into the spring. A restoring force is developed into the spring in opposite direction to Fg. In opposite direction to Fg. Fg means W. W means mg. Okay. So in opposite direction to load applied, a restoring force is developed into the spring, which restores it to initial position on removal of the load. Okay. Now when equilibrium is reached, in that case Fg becomes equal to minus Frest, or we can write mg is equal to kx, because F rest is equal to kx, or m is equal to kx by g. So we are not taking minus here with the mathematical expression, because minus is meant for opposite direction. Okay, so this way we can measure gravitational mass with the help of spring balance. And now calibration of spring. Using standard masses, elongation of spring is measured and calibration is done. Now precaution. What precaution we are to take while calibrating the spring? Calibration and measurements be done at same place, because G varies from place to place. I repeat, calibration and measurement be done at same place, because G varies from place to place. It is not essential in physical balance, in which the problem is circumvented by making gravitational force on object and standard weights equal, and then mass is read. Okay. Now, how we can measure gravitational mass by common balance or physical balance? The balance is used in grocery shop. These days we have digital, but previously this balance was used in grocery shop. Now, what is the principle of common balance or physical balance? It is based on lever principle. What is lever principle? Effort into effort arm is equal to load into load arm. I repeat, effort into effort arm is equal to load into load arm. Look at the diagram. Now P is the effort applied at the one end of the lever, F is fulcrum, and W is the load to be lifted. So effort P into effort arm FP is equal to load W into load arm FW will constitute the principle of this lever. Now in common balance, FP is equal to FW when fulcrum is exactly in the middle and the lever is horizontal. Then P will be equal to W. Okay. So when fulcrum is exactly in the center, then FP is equal to FW, and when lever is horizontal, then P will be equal to W, and the gravitational force on object and standard weights are made equal, and mass of the object is read. So this is the diagram of physical balance. You can see this is the left arm, this is the lever, this is the right arm, and here is the center fulcrum. When the lever is horizontal, then P will be equal to W. Okay. So weights are kept in one pan and matter is kept in the other pan. So when lever becomes horizontal, then the weight of the matter becomes equal to weights placed in the other pan. That's how mass of the object is read. Actually it will be mg. You have to divide the weight by g, then you will get the mass. Okay. Now measurement of mass of heavenly bodies using scientific principles. The mass of heavenly bodies is measured using Newton's law of gravitation and concept of centripetal force. Now it is the centripetal force that provides the necessary gravitational force to the planets going around the sun. For example, to determine mass of Sun, we take Earth as its satellite. Then centripetal force acting on the Earth would be MeV square by Rse, and according to Newton's law of gravitation, gravitational force will be equal to G Me divided by Rse square. So on equating the both, we get the equation MeV square by Rse is equal to G Me by Rse square. So in this expression, Me and Me cancels, and we are left with the equation V square by Rse is equal to Gms by Rse square. So from here we can calculate the value of Ms by substituting the value of G as 6.6734 into 10 raised to power minus 11 and Rse as 1 astronomical unit, 1.496 into 10 raised to power 11 meters. And V, how we can calculate V? V is equal to 2 pi r by t. So we substitute the value of t as equal to 365.25 days, convert it into seconds and substitute. So you will find the value of Ms, and it will be approximately 2 into 10 raised to power 30 kg. So you do it and see the beauty of the equation, that you are able to measure the mass of Sun where nobody can reach. Okay. Now measurement of mass on atomic scales. So it is measured with the help of mass spectrograph, and mass spectrograph is not in your syllabus, so you will study in higher classes. Now assignment 2.2 continued. Question number 16. State principle of inertial balance. How will you measure inertial mass with it? What are the factors affecting frequency of vibration of inertial balance? Question number 17. State principle of spring balance. How will you measure gravitational mass with this balance? Question number 18. State principle of common balance. How will you measure gravitational mass with it? And question number 19. How mass of heavenly bodies is measured? Calculate mass of Sun using the concept of centripetal force, and the answer would be 2 into 10 raised to power 30 kg. Now thank you so much. Here we finish with the measurement of mass, and next time we'll start with measurement of time. And thank you so much once again. God bless you.